Welcome to the Driving the World podcast series. I'm your host, Cully Holland. Today we have Keith Vieira, our industry account specialist for water and wastewater, and we're going to be discussing our TS unit. Hey, Keith, how you doing today?
Hey, Collie. Thanks for having me back.
So happy you joined us. We're going to be talking about the TS unit. That may not mean too much to our customers or even some of our employees. So let's just start base level.
What is a TS unit?
What is a TS unit?
Yeah. So the TS unit is actually it's a combination of boxes that we have, and this was created really for the clarifier market in the water wastewater industry. Pretty interesting story on how it started and why it kind of came up, but TS is really torque sensing, torque monitoring.
Love it when it makes sense.
Yeah, right. Super simple. So what is it? It's a simple combination of boxes and springs to detect torque as torque is increasing in a clarifier. As it goes down and torque starts to increase, the springs start to pull over, and it just, as a pickup, it just picks up mag sensing. So we have two switches, gives us an alarm signal and a shutdown signal. So why do we need that?
Yes. Why do we care about torque sensing or shutting it off?
Yeah. So in these boxes and these applications, as torque increases down below in these clarifiers, if we don't have some mechanism to shut this down, that whole cage and rake assembly can just twist like a pretzel. So the product was developed to just help downstream equipment.
I mean, that makes sense to me. I know a little bit about clarifiers, and I know they can be quite large. So I think making a pretzel out of a rake would be a quite dirty and quite expensive mistake
Quite costly.
that you don't want to be dealing with. And it sounded like it's a pickup, a mag pickup, something that's going to be rather reliable. So it sounds like a good solution to me. But when we're talking about torque, I mean, are we talking about 100 horsepower motor? Are we talking about what kind of speeds are we talking about that we can generate this torque that's actually going to shear or pretzel these clarifiers?
Right. So the amount of torque that's required for this to move that body, that massive rake and the sludge that's fallen here, because that sludge blanket inside a clarifier can rise and fall based on the daily activity, right? So with it, there's a variable amount of weight that's on that clarifier. So as that clarifier turns around, those mag pickups, as it starts to increase torque, they'll move over and hit those sensors. But because the torque is transmitted all the way through that box, you don't need a large amount of horsepower to do this, right? The amount of torque is just a fractional amount of horsepower that's needed. So that little bit of horsepower can turn a big, big box.
So it sounds like we're talking what, 1-2 horsepower motors here?
Even lower.
Even lower than that.
Even lower, yeah. So we're fractional horsepower.
So what is the output speed then? Because I mean, that's a small horsepower, and we're generating this much torque to pretzel a clarifier?
Yeah. So the amount of torque generated all through there, the ratios, we're turning less than 1 RPM.
Okay, that makes sense.
Think
There we
about
go.
that.
Yeah.
Think about that speed, right? 1 RPM. And we have ratios that are even lower than that. So the amount of torque that's generated through that box, it's just fractional horsepower.
That is wild to think about, going from probably a 4-pole 1750 motor down to under 1 RPM.
Yeah.
So this sounds like a rather nifty, handy solution to what could be a very expensive, cumbersome problem.
Yeah.
Is this new to SEW? Or did we just launch this, or is it tried, true, tested?
So it's funny thing is this was actually developed in the late 80s.
Oh, okay.
Right.
It's tried, true, and tested.
This has been around a while, right? This actually came around with our old ops manager in Dallas, a sales guy, and a sales engineer. Right?
Perfect.
So those three kind of came together. They were at a trade show, and they said, we need some type of reaction-based detection. What is reaction-based detection? So it's a method of creating some sensing device that'll help downstream equipment. So this came out, they drew this literally up on a napkin. How do we do this? How do we draw this up? They kind of came around with this idea, and it's a compound box with a spring set in the middle that allows this pickup to happen. So it's been around a while.
I mean, that is amazing. Since the 80s, if it's still around, it has to work. Just for some folks listening, a compound box, just so we can clarify that, is going to be a motor with an intermediate or secondary gearbox going into another gearbox. And that's how we're going to achieve those extremely high ratios.
Correct.
So something I would want to think about, okay, it's been around since the 80s. It's tried, it's true, it works, but technology advances.
Right.
Is this going to play nice, or do we have any use of controls or VFD technology with this application or this setup?
Yeah, so we can use a VFD, on this to control speed once the unit's up and running, but we're not going to use any type of electrical components to monitor torque, right? In those fractional horsepower motors, the magnetic current just to turn a motor, right, is the slip in the motor for an AC motor, right? You have very little active control in there, so you're working in the noise of the motor if you're trying to operate there, right? Larger horsepower motors, so you can control those easily. So you have to have some mechanism in there. This one happens to be mechanical and springs to do a shutdown on the torque.
Fantastic. So our drives, controls, and automation can be used, but we're still going to have our mag pickups. Make sure that torque doesn't go over the needed capacity. And let's just touch on, pretty much most of the things SCW can offer. We have our heavy industrial gearing as well. Does that have any home in this realm or in this scenario, or is it really just mainly the 7 and 9 series?
Yeah, no, great question. So with this, we can tie the electronics on the front end of this, but on the back end of this, on the very bottom of the TS unit, we can actually add planetary or our big heavy industrial gearing on this for even larger gear ratios to go through. On these applications, it's not, you're going to be off clarifiers now. Now you're going to be on process equipment, say like sludge collectors. You're going to be on screw presses, things that turn very, very slow. So this is any application that's going to be small motor, heavy gearbox, slow operation, low RPM, right? Anything that you need some downstream protection on some equipment, that's where this is the sweet spot.
I mean, that's amazing. You kind of beat me to the punch. I was hoping we get a few more applications out of you, and we did. And it's sounding like you said, small horsepower, generating a large amount of torque at slow speeds. And I feel like all those applications you just listed, the sludge collector, the screw conveyors, the downstream equipment, hard to replace, expensive to replace, timely to replace. So this is going to be kind of one of those little safety factors or quick preventive maintenance ideas that we can have to where we're protecting all of our equipment, not just the motor or gear motor.
Exactly. Yeah. The great thing about this is we've had it for a long time. We've got a lot of runtime with this piece of equipment. We just want to showcase it to the world now. I mean, honestly, this is a piece of equipment that really has a lot of other applications, right? I'm in water, wastewater, but there are so many applications out there that this can be used for. We just want to bring some attention to it.
I mean, I've been here coming on 12 years and I had heard TS
What's a
units.
TS unit? Yeah.
Yeah, I was like, I heard it, but it was something we had, and I already feel way more comfortable with what it can do and where it fits into the industries. So I think we've had a really nice 10,000-foot view, kind of covered the TS unit, hopefully taking away some of the mystery.
Yeah.
Is there anything you would like to touch on, a final note, or if we about got it covered?
Yeah. So these things are made in our Dallas office, right? So engineered and made strictly in our Dallas office because that's where it generated. That's where we make it. So if there's any questions on this, have them reach out to me and, or our Dallas facility, and we'll be happy to help people out.
Fantastic. You heard it here first. Keith Vieira is your TS unit guy and or Dallas Engineering, or of course, any of your local sales rep, you can reach out to them and they'll get us connected with the proper people and right information.
Yeah. Thanks, Coley.
Thank you, Keith. I think it was a lot of fun and I definitely learned something today.
Appreciate you.